We've got Shuveb, who's going to come talk to us about real-world data prep for LLMs.
Good evening. Thank you for coming today. I'm Shuveb, one of the co-founders of Unstract. I'll be talking to you about how to prepare data for consumption by large language models. Before that, really quickly, right? So we're open source. We have about 1,000 plus users. Paid customers process about 7 million pages a month or so, and this is growing really quickly. So that's about us. We are a fully distributed team. We have about 35 folks in the organization, right? So really quickly, PDF challenges. There are many. Usually, when you have to deal with PDFs, you don't get like straight PDFs. The PDFs are super complicated documents, and it's also made complicated by the fact that the software that creates the PDF can make things really hard for you, right? You can have tables, you can have PDF forms, scanned documents that are scanned really well using a flatbed scanner, documents that are scanned like with like a smartphone photo, handwritten scan forms, all sorts of problems, right? So the thing is that when you have to deal with PDFs in the real world, you can't really expect clean PDFs to be dealing with clean PDFs all the time. So you will have PDFs that are, really super complex to deal with. That, that's how it is, right? In the real world, right? And when your PDF processing fails, that means businesses have to resort to manual processing, which is expensive, slow, and not to mention very error prone, right? So why is PDF parsing so hard? So I'll rush through this section because, I really want to spend time on the code more than anything else today. So first is that PDFs are designed for fixed layouts, right? But unfortunately, PDFs are a very common document type when it comes to data processing by large language models, right? Any business, PDFs are really the standard, right? So you do have other document types, but the PDFs are super common, right? Scanned PDFs are, for example, this is a common kind of a screenshot where I'll be using LibreOffice or some software thereof to show you the structure of the internal PDF. In this particular case, although the document is a PDF, if you look at the right side panel, you can see that, the page contains quite literally just one image, right? There's no other component in there, right? So you could have other problems like lighting conditions, rotation, skew, obstruction with the finger, things like that, and compression artifacts are also fairly common, right? Now, many PDFs, they look like scanned PDFs, but you will be able to select text sometimes. That is because PDFs do come with internal OCR systems, but then the quality of this internal OCR can differ quite a bit. So in this particular example, you have this, heading called learning algorithms. But then when you look at the text that is OCR'd on top of it, there is double spacing in there. So if you literally search for learning algorithms, you won't find the text. This is a very common problem that you'll see with PDFs, right? The quality of the internal OCR can differ quite a bit between, some of these systems, right? So searching versus extracting text is a huge challenge, right? Now, tables are another very common component that you'll need to extract from PDFs, right? And then you'll have there's a lot of libraries that say that, hey, we are able to extract tables for you. We'll see some examples of that in some code. But then again, Camelot, Tabula, PDF Plumber, these are some very common open source libraries that you have that help you, extract tables from PDFs, right? Now, some of these systems are rules-based. Some of them use computer vision and all kinds of system machine learning. Some folks use hybrid approaches, but then your mileage may vary, and you'll have to figure out how good an extraction system you need based on the quality of the input for PDFs that you generally get, right? Page orientation is another problem, especially for scanned PDFs. This can be pretty challenging because not all OCR systems are equipped to deal with orientation changes, right? Now, another common problem is that you will find text, but then if you go inspect the PDF, you'll find that every character has been basically drawn as a shape, right? Which basically you can't get the ASCII value of it. So it's very difficult to process that way, right? So That's where if you look at the inspection, right? So the A here, or in fact, every letter there is rendered as just a bunch of Bezier curves, right? So that's another headache that you see. Then when you pull out data from a multi-column layout, you'll have to semantically do it. Like for example, in this particular case, when you have like a 2-column layout, you'll have to go column by column. If you pull out the text across columns, it's not going to make a lot of sense, right? Again, multi-column layouts are important for things like forms, where you will have to preserve the multi-column layout. Otherwise, it won't make a lot of sense. And then when you have, watermarks and such, they tend to confuse OCR systems as well, right? Now, handwritten forms are another challenge that you'll find in the real world. For example, in India, we are dealing with a customer now where, insurance agents go fill out hand forms. They come back to the office and then they'll have to go then process those forms, super challenging, right? Not all OCR systems actually are capable of, understanding handwritten text. So again, you'll have to figure out, depending on your use case, you'll have to figure out, what you need to do there, right? Now, PDF elements, for example, just like you can hand fill PDFs, there are some PDFs that can be electronically filled out. Not all libraries are capable of pulling out information that has been electronically filled out. So we know that, for example, PDF.js can do that, but then that's in the Node.js ecosystem. So if you're usually using Python, then you'll have to maybe run that as a service, then build call that and then get things done, right? So that is something that you might need to do. And then interpreting checkboxes and radio buttons is also a very common theme in PDF parsing applications, right? So here, for example, citizenship, type of credit, marital status, all those are places where you'll have to interpret the checkbox or radio button, for example, right? Now, these are some of the building blocks that any production grade PDF parser will need to have. And then depending on the kind of PDFs that you deal with, you may or may not require some of these modules. But then again, anything that's professional needs to have at least these modules in place, at least, right? So this is more of a starting point, really, right? So what we'll do today is that I'll show you, for example, how we can take a bunch of unstructured documents. We will we'll compare and contrast a bunch of open source libraries and common, more popular cloud services that are available to pull data out of PDFs. We'll get the raw text from these services or libraries, and then we'll use Pydantic, a very popular Python library, and also combine that with LangChain just for templatizing prompts. And then we'll convert that data into structured JSON. That's really what we want to ultimately achieve. So in goes a document, out comes clean JSON data, right? That's what we want to achieve. And then we look at different approaches that we can actually go and, right? So very quickly, what we'll do is we'll look at a table extraction from PDFs. We look at PDF forms that have been electronically filled out. We will look at 2 types of scans. One scan is a pretty good scan, maybe like done using a flatbed scanner. Then not so decent scans. For example, I just took my smartphone out and I clicked the picture of a form, or I have a driver's license, but the orientation is completely off. Let's look at those examples. Right? Those are, like I said, real-world examples. Finally, we'll also look at handwritten forms, which are also fairly common in the real world, right? So there are some challenges when using large language models to do some work like this, hallucinations and things like that. We're just going to very conveniently ignore all of those problems and just assume they're not going to happen. But for the sake of this particular talk, this is more than enough, right? We will look at 6 different libraries and services. We look at PDF Plumber, Camelot, Tabula, Unstructured IO, Llama Parse, and Whisperer is the service that we work on. We have a technology called Layout Preservation Mode, which I'll show how it really works, right? Now let's look at some PDFs and how they work, right? I'm gonna move over. Oh yeah, it's right there. Okay. So this is an example of a PDF that we will look at. Let me zoom this over. So this is a Apple 10K report, and we are very interested in this particular table, which is on page 14, right? So the challenge with this table is these 2 columns we have called 3-month ended and 6-month ended. And if you look at these columns, they are merged columns, right? So 2 columns are merged here, and the other two columns are merged here as well. So, and this is a fairly simple table, number one. And number two, this is a native text PDF, right? I'm able to select all the text. This is like as clean as PDFs actually can get. And you'll appreciate that this is actually a fairly simple table, right? I mean, there's not a lot of merged rows, not a lot of merged columns. Fairly simple, but still, I mean, very challenging to process. That you'll see, right? Now, this is a credit card statement, apparently from Larry Page. So this particular statement, what we are interested in is actually grabbing these line items, the actual spends, right? We'll see how we can achieve this, right? Then we will look at a simple form. This is called a 1003 form. It's like a loan application. As you can see, this one has been electronically filled out. So the name of the person, social security number, date of birth, and all that, including the check boxes and all those. These are electronically filled out. I mean, this is a very common application again in real world data, right? Again, this is the same 1003 form, but filled out using handwritten text, right? And the second challenge is that we'll have to interpret check boxes and radio buttons that are again, checked using hand, right? And then finally, we'll look at an example of a scan which is off orientation, right? And which library is able to handle this, right? The last example is that of a photo of a receipt. Again, a very common problem. So, for example, expense management apps and, a lot of these apps actually have to deal with this kind of data, right? So these are some of the examples that we'll deal with, right? Now, coming to the actual code, I'll quickly show you how some of this might work. So not exactly, okay? So this is one. Let me try and grab the other. Yeah, this is, okay. Okay, yeah, this is Camelot. Unfortunately, you're not able to see the headings properly. As you can see, we'll use Camelot here to extract tables. Then this is PDF. This is Tabula. This is, I think this is Llama Parse, Unstructured.io, and then LLM Whisperer, right? So these are all different libraries we have, and we'll try and extract, files from, tables from, these particular files, right? Now, I'll have to go back to show you the, to quickly remind you, what we'll do is that we will look at, some of these PDFs, right? So first is we look at the clean PDFs where we'll have to extract this table and this table, right? And then we look at how we can extract data from, these, this PDF, this electronically filled form, the handwritten form, and finally the receipt, right? Now let me go and start a terminal here, push it over there. Okay. All right. So I have a couple of scripts that make it easy so that we can save time. I'll just start this particular script called run OSS. So this should start, you can see at the bottom here that I have Camelot and then for two different clean PDFs, right? Now Camelot for the first PDF, which is the credit card, right? It failed pretty badly because it sees only one table in the whole PDF, right? So not such a great result after all, right? So next is we can look at Camelot 2, which is the Apple 10Q document. It did not find any tables at all, right? So which is very strange because it's really a clean PDF, right? Then when it comes to PDF Plumber, I do see some data here, but it's not very impressive, right? So if you take a look at, for example, this PDF, it hasn't really. It's just found something from here, but then it did not consider this particular table as actual table for some reason, right? So that's pretty bad, right? So let me go to the next, which is actually PDF Plumber did find some information in the Apple 10Q 10K report, which is not bad, but then the columns are not maintained. So this is actually pretty useless for us when it comes to processing this data, right? Let's look at Tabula next. Tabula again has found some tables in the first page of the credit card statement, but then again, it did not find the table of spends there as well, which is not great for us, right? So yeah, so and again, this is the Apple statement where we had like a merge column and all that. Again, not a great job. This is actually not very usable when it comes to dealing with this kind of data. So I'm gonna close this out, and now that none of the open source libraries are actually able to deal with even clean PDFs, I'm going to completely ignore them for the rest of the more challenging PDFs. So, we will not deal with open source libraries anymore, right? So next is we look at the same thing with Llama with unstructured.io. So let's take a look at that and see how it deals with those, right? So here are the clean versions, the clean PDFs, right? And the other PDFs also you have seen, which are kind of more challenging, the handwritten PDFs and all that, right? So let's move and see how it works there. Okay, so we have some data here, which is the PDF form data, but unfortunately, we don't see any extracted information properly. So if you look at the data from here, the electronically filled out data is completely missing. So I do see some information here, the borrower information, but I actually don't see if you look at the first name, last name, social security number, I do see some data here, but then AMI America was the data that was filled out. I don't see that here, so I don't think this is going to work as well, right? As for the handwritten text, again, it's not working properly, because if you look at the driver's license, it's completely not very legible here. So it hasn't worked there as well. Let's look at the handwritten, the smartphone clicked photo. We have some information, but this is unfortunately not very usable. And then the name of the extracted items are all, pretty illegible, right? Although this was a fairly decent photo, right? So this is the problem, when it comes to more challenging PDFs, these are actually failing pretty badly, right? So again, this is the Apple 10K report. This is actually okay. The extraction seems to be pretty decent, but then again, the table structure and all that is not maintained very well, right? So we're gonna again compare this with, let's take a look at how Llama parse, whether it's able to do a decent job. So let's run, okay. We're starting Llama parse for these files in different terminals, okay. Actually not bad. Let's look at the spend line items. We have a decent conversion to markdown. So Llama parse, good job. This should work really well for us, right? So let's look at other, yeah, okay. Why is this? Oops, 1v1. Okay, there you go. So this is the table that we got. Unfortunately, the merge column layout isn't really preserved. That is because in Markdown, it's very difficult to... Markdown has no syntax for merged columns. So there we seem to have lost, some data. This is the handwritten form. Again, it hasn't done a great job. So it seems to be working well for clean PDFs, but not so much for the handwritten PDFs in this particular case, right? So let's look at number 4, which is the smartphone captured image. Not bad. It got the receipt pretty well, but then I see 3 items, whereas in the original receipt, there were only 2 items, right? So there's the Jack the Ripper plus fries and then Coke, only 2 items. But for some reason, Llama parse thinks there are 3 items, which is actually wrong if you look at this here. So this is going to confuse the large language model quite a bit, right? Now, as you see, as the complexity of the PDFs increase, we have trouble. And then let me get out of this and finally look at Film Whisper, which should give us, we look at what we call as the layout preservation mode. We should look at, give you a good idea about how layout preservation works, okay? So this is layout preservation mode in action. So it preserves the layout of the original PDF. So if you look at the merged columns, you're able to see that, This is across these two columns, and this is across these two columns as well, right? Now, this is a very important technology because large language models, it turns out, they're really good with when the layout is preserved, from the input document to the raw text, right? So we'll see more examples of this, and then we look at 3, 2, okay? Now, this is, again, the PDF form. As you can see here, the layout is again preserved. So if you take a look at how, for example, we render checkboxes and radio buttons, you can see that these are interpreted, and you can see literally how you can see the form because of the layout preservation. And if you look at how checkboxes are rendered, right? And turns out large language models are good when you actually do this, right? Okay, this is the receipt. Again, layout is preserved here, as you can see. If you can, the layout is carefully preserved, right? And this is the handwritten text and the driver's license, which was completely off orientation, right? And you can see that, handwritten text, we managed to get everything perfectly out, right? So again, citizenship, this was hand checked. These are all hand checked. There's a handwritten text, right? And yeah, so we can take this and then pass it to a large language model and get pretty decent data out, right? So let's do that. We only have like approximately 6 more minutes, so we can probably do that, and then, okay. Oh, okay. So what we want to do is we want to use LangChain to extract structured data from this particular text, right? So I'm going to mount the text. Okay. So I'm just using 3 different documents from the previous set. Calling LLM Whisperer, it's got the layout preserved text. Then you should see JSON data scroll by, and later on we'll use the same thing using llama parse. We'll see how, for example, layout preservation works versus how, for example, markdown works, right? So that's you see the JSON data for the LLM spend, and this is the Apple statement, right? All the code is available on GitHub. I'll pass the links to you, Jan, so you can check out the repos. And from this, we should have clean JSON data back for both the 3 months and the 6 months quarter ending, right? So as you can see, and finally for the this particular receipt, we have perfect JSON data as well. So we have the vendor name, the purchase date, and this time only 2 line items. So this is I think this difference is very crucial. So we look at the original from llama parse, you saw that there were actually 3 items in the markdown, and so the large language model is very likely to return 3 items, not 2. But in the receipt, you had only 2 items, right? So the thing is, if you move the intelligence to the large language model rather than trying to somehow make the document look like perfect markdown, you'll have better results. That's actually that's actually what we have seen, right? So if you try to somehow convert the document into, for example, here, it's as you can see, right? I mean, it did not get it for Europe, Greater China, right? That is the reason is that the large language model is looking at the markdown and trying to figure out what it is, right? Yeah, there you go. So here you have 3 different items, which is wrong, right? So the problem is that when the large language model is looking at a markdown, it's trying to interpret the markdown. But if you preserve the layout, then it's able to figure out that there's only 2 items, not 3, right? So this is a very common problem that we see. For example, let me show you this. So in this particular case, it's taken this as 3 different items. It was actually only 2. So in the JSON output, you actually see 3 different items, right? Which is a problem. And if you go back to this particular table, it did not interpret it for Europe, rest of Asia Pacific, stuff like that, right? So, but if you go back up, so it's doing a good job with the credit card statements, but then for more complex document types, it's not doing a good job because of the conversion to markdown, right? So, I just want to finish. I just want to finish with the last few minutes. So this is the comparison of the different libraries. Unfortunately, the open source ones failed even with the clean text PDFs, and forms and handwritten handwritten text pretty bad, right? At the same time, llama parse renders everything as markdown, right? So it works in some cases, not so much in others. Where layout preservation mode does a really good job with many different types of input documents, right? Now, the approach that I want to really harp on is that there are two ways in which you can pass input to large language models. One way is that you can attempt to structure the document in a way and then pass it to large language models. Our learning is that don't do that. Rather, you preserve the layout, you let the large language models decide how many rows are there, how many columns are there, and they do a way better job with real world data, because like I said, we handle about 7 million pages a month at this point in time for the paid customers. The free customers are a lot more. And then, this is what we have learned, from our work. So, yeah, thank you very much. That'll be my talk, yeah.
See, 2 questions. Okay, we can take 2 questions. Does anyone have any questions they want to ask? Yes, in the back.
Hello, how you doing? Ricardo here. I'm a startup founder for an HR tech company, and one of the implementations that we are doing is we're hosting all of our resumes from 350,000 plus users globally on bucket storage in Google Cloud Storage. And one of the solutions that we're working on with Google is pretty much scanning and identifying some of the PII information. And the problem that we have, and that I would like to know if your solution is able to help with, is once they identify that PII information, there's multiple methods that we can rewrite it, right? We can use hash or tokenization or something like that to remove that information. The problem is rewriting that back into a PDF format, right? Is there any way that your solution can connect with something? They have a tool that is called DLP, which is for data loss prevention. Is there any ways that you guys can connect with those tools to be able to rewrite and remove any PII information that gets identified on any of those resumes data?
I see why that can be helpful, but what I don't understand is why do you need to write it back to the PDF? Now, once you have the raw data, there's solutions available in the market that can do 2 things, right? They can either remove PII data, which just like, for example, replacing them with a bunch of X's or Y's or Z's or whatever, or they can anonymize the data by replacing them with a token and then giving you back the data, once, for example, when you need it, right? So these are 2 approaches that people take. But then what I have never seen is that people somehow directly manipulate the source PDFs so that, you somehow replace the PI in there. So the better approach would probably, in my opinion, would be to, once you get the raw data, use a system that can essentially anonymize PII, send that to a large language model, but you will have to trust the raw text extraction system, right? That's the reason why LLM Whisperer are usually available for deployment on-premise as well.
Cool. One more question. Anyone else have any questions? Someone? Okay.
So how are you actually structuring the end output? Is that like a LangChain thing? So it's JSON mode?
Yeah, I didn't have time to cover that. So, I'll pass on the repos to Eugen here. So there are 2 repositories available. One is basically just comparing different libraries and services for raw text extraction. The other repository uses Pydantic and LangChain. So in Pydantic, we define the structure in Python, and then you describe the fields, and then it creates the prompts required automatically to instruct a large language model to take this raw text, but then again structure the JSON data in a manner that you want. It's just Python code, yeah. Pydantic is the library we use, yeah. If the code is there, I'm going to share it, yeah.
Yeah, I'll send it out afterwards.
Thank you.
Thank you. If you have any more questions, you can ask Shuveb afterwards.